You'll find it hiding in shadows. You'll find it hiding in...
And welcome to the video on the derivative as a function. Okay, so first of all, let's go over the term differentiable. So differentiable, that refers to a function. Okay, so a function is differentiable on open interval a, b. This is our open x interval if f prime of x exists for all x on that, or on or in, I'll say in a, b. Okay, so that's just an umbrella term, right, for any function for which an f prime of x exists for all x in that interval. Okay, another thing I want to go over is something called Leibniz notation. Okay, so again, this says notation. So this means that whenever you see an f prime of x, so that would be the first derivative of our function, right? So this is going to be the same thing. This is what we're used to seeing, and this is equivalent to saying df dx. And these d's mean, they're like differentials, okay? So the change in f over the change in x, and it means tiny change, okay? So anyway, so this is the start of Leibniz notation, as well as dy dx. Okay, this is also Leibniz notation. So that represents the smallest change in y. How does the smallest change in y respond to a tiny change in x? Okay. All right. So these are just symbols, another way of representing what our first derivative. Okay. So example would be, let's say we were to have f of x is equal to x squared. Then we have that f prime of x is equal to a 2x, okay? Also known as, what we could have is write our f of x down, so x squared, right? And then if you write d dx in front of it, that means we are taking the first derivative with respect to x. This is our Leibniz notation here. And then you would get out a 2x, okay? Also, something to note is that if you see something like this, and then a line, and then x equals like 4 or something like that, what this means, what this signifies in the bottom right corner, is that you take the first derivative with respect to x, and then you plug in a 4 for your x to actually evaluate the derivative at that point. Okay? Alright, now on to a new topic called the power rule. Power rule. So this is one of the most important things you're going to learn about differentiating. It's definitely one of the most common things that I see when I take the first derivative now. So basically, what we have is for all exponents n, okay? Then we have that if we have an x raised to the n power, if you differentiate that, if you do d dx, okay, then what we have to do is take this exponent, we're going to move it down here, right in front of the x, and make it the coefficient. So we have this x to the n, and then we move this n down as well, okay? And then what we have to do is subtract 1 from the exponent. So that means put a little minus 1 there. So what we added was the n here, and the minus 1 on the exponent. Okay, so this is how the power rule works. This is kind of like a shortcut, sort of, so you don't have to go through the entire like definition of the derivative process and then etc., etc. So this power rule here, I'll write it down here without any marking. So d dx of x to the n power is n times x to the n minus 1. Okay, so that's the power rule. It's going to be coming very handy, and this is valid for all exponents, including the following, including negative numbers, so including negative numbers, fraction numbers, decimal numbers, irrational numbers, etc., etc. So it's valid for everything, basically. Okay? Alright, and just it's important to note that it could be used with any variable, not only x. Okay? So can be used with any variable. Okay? Not just our x. Alright, now for some linearity rules. So linearity rules as far as differentiating goes, okay? So linearity rules, so first of all, we're going to assume that for all of the things that we'll see above, or below, sorry, all the things we will see below, we're going to assuming f, the function f and the function g are differentiable. I'll abbreviate differentiable, okay? Then we can say that f plus g, so we're adding the two functions and then taking the derivative. So that's what that means, and this is going to be equal to if you take the derivative of each separately and then add them together, okay? Alright, and the same is true with subtraction, so if you do f minus g, the function of f minus the function of g, that would be the same as if you were to do them separately, calculate the derivative separately, and add that minus sign in between after, okay? And then also, we're going to add in one more, so for any constant c, constant number, c, cf is, and again, our f is our function, c is a constant, is differentiable, and c times f, so this is like 2f or 3f. The derivative of that is the same as taking the derivative of just f and then multiplying by that constant later on, okay? Alright, so now let's do a practice problem.
I didn't even notice when the sky turned